time on Voice of the Sea, we're learning about the link between cesspools, groundwater, and the ocean. Research shows direct connections from cesspools to contamination in our groundwater and the nearshore environment. Hawaii has more than 88,000 cesspools discharging over 50 million gallons of waste each day. And many of the cesspools are concentrated in low-lying coastal zones, making these areas extremely vulnerable to damage from chemicals, disease, and excess nutrients. We start off talking with groundwater inundation expert Dr. Shelley Habel to learn more about how ocean water and groundwater interact near cesspools.
So each cesspool needs about 15 feet of unsaturated soil space. So that's the distance between the ground surface and the groundwater. The idea there is that pathogens get cleansed as it kind of trickles through that filter. We were simulating levels of groundwater so we could see by comparing that to the elevation of the ground surface, how much unsaturated soil space you have. The Department of Health has a GIS layer that shows where the cesspools are located. And so we just overlapped that with our data that we had to figure out what cesspools didn't have that 15 feet of unsaturated space. And we found that the vast majority of cesspools now don't have the required amount of unsaturated space for them to be considered effective.
And how is that going to change as we move into periods of higher and higher sea level?
So obviously, as sea level comes up, groundwater floats just like a boat on that seawater, and so it'll come up, it'll lift up, and so that unsaturated space will narrow. And so we're going to see more and more areas where, you just don't have that necessary amount of space that you need for a cesspool to be functional. And also, as sea level rises really high, there's some places where that groundwater comes up above the ground surface. So then you have that contamination on the ground surface where we're all walking around.
Can you explain that? That's just so scary. I had to have a moment to think about walking around in the streets flooded with my cesspool water.
It's happening in Mapuna Puna now, actually. We not only found that the flooding that we see is groundwater, but that it is contaminated. As groundwater flows through the ground, it picks up this element called radon. If you find that radon in your puddle, that means that there's a certain amount of that water that came from the ground. So we tracked the amount of radon that was in the water as the tide came high and went low again. And so we saw this pulse of radon come up. That means that groundwater was pulsing up through the ground into those puddles. And same thing with cesspool effluent. So they have their tracers that are found within the cesspool effluent, and we found that pulsed up as the tide came high.
In your research, you've identified Mapuna Puna as this very noticeable area where we get groundwater flooding. You can test it, you know it's fresh water, it's coming from groundwater. Are there other areas in the Hawaiian Islands that you think may be having similar problems just based on geology and your knowledge of flooding that might not have been tested yet?
I think Waikiki is next. We're starting to see impacts in the form of basement flooding. And also, so roadway, it has its structure on the ground, but if you have really shallow groundwater, that structure can fail, and then we can start to see potholing. In a lot of really low-lying areas, you see a bunch of potholes, right by the shoreline and stuff. There was a study that looked at the effect of shallow groundwater on roadway, and they found that it has more of an effect than weight and temperature combined. We presented this information to the DOT, and their minds were blown because they're like, oh my God, along Kapiolani, where we've been fixing pothole after pothole and they keep on coming back, this is likely the reason why, is because we have these really shallow groundwater tables.
Next, Dr. Tracy Wigner shows the work that she and her colleagues at UH Hilo are doing to better understand the connection between cesspools and nearshore reefs. What about the influence of cesspools? How are they affecting pathogen load into our watershed?
They're coming in through the groundwater largely. The cesspools, basically an open hole that the wastewater from the home goes into. And then the rocks on our islands are so porous that it doesn't take long for it to percolate down to the water table and then make its way to the ocean. And it's a particular threat when you're looking at homes that are right near the shoreline. There was a study at Waʻiʻi, I guess almost 40 years ago now, it was in the 80s, and they found the transport time was 25 minutes.
Oh my goodness.
And then the work we've done at Pu'uko has shown anywhere from 3 hours to 9 days, depending on where the house was located. In one place, my colleague Steve Colbert put the dye into as an aerobic treatment unit. And it was cracked, and they knew that at the time, but the cracks must have lined up perfectly with fractures in the rock, because all of a sudden, within a couple hours, the water in front of the house started turning bright yellow. My colleague Steve Colbert, he goes out, he has a giant carboy full of fluorescein, which is a non-toxic dye, and then he would pump it into one of the cesspools or the septic tanks or aerobic treatment units. And then he would map out along the shoreline in front of the house. He would find out where the springs were located. And then he would set up a protocol to go sample those every few hours to see when the dye would emerge at the spring. And then he would follow that for about 2 weeks to really see when the peak of it would come out and then when it would start to trail off. We measured a lot of the standard parameters used to detect sewage, so nutrients, fecal indicator bacteria. We also use some new, more molecular approaches, looking for a specific bacteria called Bacteroides, which is the most abundant one in the human gut. And with the nitrate isotopes, we can look at the nitrogen and the oxygen part of the molecules and do some modeling to figure out what percentage of that nitrate came from sewage or other sources like fertilizers or Upmalka groundwater.
The University of Hawaii's Sea Grant College program focused on Hawaii's coasts and its communities through sustainable development, safe seafood supply, sustainable coastal tourism, hazard resilience, and healthy coastal ecosystems. Hawaii's Sea Grant.
We're talking with Dr. Daniel Amato to learn how University of Hawaii researchers and local communities are working together to monitor water quality and trace cesspool contamination.
You can think of the island like a large toilet. When the tide goes out, that's like you hitting the flush button, and all of that groundwater that may be contaminated in that nearshore area underneath the beach, near the beach, that gets flushed generally into the nearshore environment. And as the tide comes back up, it pushes that kind of fresh seawater back up into the island, and the cycle repeats itself. The big question is it safe to be in the water in these areas where we're detecting high amounts of wastewater? We can detect the nitrogen out there, and we know that there's wastewater and that there's nitrogen derived from wastewater. Can those viruses, can those bacteria, are they transported through the sand and the sediment, or they just go straight into a lava tube and fly right out at the coast? As a water scientist, I've seen all kinds of ways that water can discharge into the nearshore environment, and at times it's a geyser. It comes up, it literally boils at the surface of the reef. And so there's areas where there's this really intense direct discharge of groundwater right into the coastline. And there's other areas where basically the beach is a huge sand filter and potentially filtering out virus particles and bacteria before they can actually enter the ocean through this sort of diffuse seepage, as we call it, of submarine groundwater discharge. Personally, right now I'm leveraging the power of the Blue Water Task Force with the Surfrider Foundation here on our Oahu chapter to tackle some of these questions and really provide an additional data set that will be very valuable to the state when it comes time to answer that question of, is it safe? Is there a risk from a recreational point of view? I don't think that question has been answered yet, but I'm really interested in finding the answer to that for sure. In areas that we expect there to be a fair amount of wastewater in the ocean, we are seeing it in our tracers. We're seeing it in those nitrogen isotopes in the seaweed tissues. We're seeing it in the water samples. All this work that we're doing is reinforcing that we actually have good models, and the models are probably our best tool for predicting where we're going to have impacts, even if we haven't measured it there yet.
How has your work been impacted by the coronavirus stay-at-home situation?
The completion of our fieldwork has been highly altered by the coronavirus stay-at-home, work at home. You can't really investigate wastewater from your house that easily. That being said, we can still make maps and models and look for trends. But yeah, we're looking forward to wrapping this up. We got a couple more collections we'd like to do on Hawaii. We're basically starting the analysis game right now and looking towards writing this up this summer and having it available at least as a draft as soon as possible.
I'm interested to know how our community can help with researching the water quality issues you're talking about.
In Hawaii, there's a few groups that are doing really great sampling. The state is fortunately underfunded and undermanned, so they really can't reach the capacity that some of us would like them to. The citizen scientists play a really important role of being those boots on the ground and eyes on the reef, where they can identify problem areas that the state might overlook and go out there and sample them and respond to events as they happen. For instance, sewage spills and things like that. We've had citizen scientists be able to go out there with a moment's notice, take a sample and run it. And this has led to a pretty good relationship with the state.
If I notice that my river, my local beach seems more polluted than it usually is, or I'm just worried because it's chronically polluted, how can I get involved with one of these citizen science groups?
If you were on Oahu, I would say you'd probably end up emailing me at the Blue Water Task Force Surfrider Foundation Oahu chapter and say, hi, my name is, and I think there's a problem over here and I'm willing to help if you will show me what to do. And that's usually how it starts. We have, concerned citizens that call us. I will personally train citizen scientists in how to take water samples. Right now, we are very blessed to have access to the Koala Marine Laboratory in Kaka'ako. That's a UH marine laboratory, to do our work there and run these water samples. What our research is basically telling us is that our modeling is the best tool that we have. All the water quality results and the seaweed results, they're basically just validating the model and saying that the model is predicting where we're going to find wastewater really well, where we're looking for it. So we should basically use that as our best information that we have right now and move forward with prioritizing these areas for upgrades. There's so many different varieties of situations hydraulically and geologically here in Hawaii that it really requires a more fine-scale approach to determining what kind of solution is going to work here and what communities are really at risk of impacting their own coastlines. There's not going to be a one-size-fits-all solution. We have to really consider the unique geology and hydrology of every neighborhood that we are discussing. My mission over the next 2 years or more with the Blue Water Task Force is to use this program to help this Act 125 effort and the effort by the state to uncover this big question we have: is are cesspools and other wastewater sources linked to higher levels of bacteria in the ocean? The big question is this having a long-term impact on our reef? And is it having a long-term impact on our public health? And is it a risk for our kids to be using these areas on a daily basis? And so I don't think we're going to know that answer until we really put the time in and do a larger statewide study. One thing that we're developing through a joint effort with Surfrider Foundation, with the University of Hawaii, and a private company, Diagenetics, is a near real-time DNA detector or quantifier. It's called the BioRanger device. In theory, we'll be able to get a count of fecal indicator bacteria at the beach in under an hour. We're hoping to roll this out this year. My experience from my work in American Samoa is that every major public beach in American Samoa, there's a sign and there's a green happy face or a green dot if the water was good during the last round of bacterial testing, and a red sign if the water had too much bacteria. And I'm thinking, if American Samoa can do this, then Hawaii for sure should be able to do this. I think we have a right to know as the public what the water quality is and make our own decision if we want to enter the water or not. In my vision for the future of Hawaii and potentially this country is that every lifeguard will have the ability to test the water quality at the beach multiple times a day, because it changes with the tides. Every time the tide comes in and goes out, we kind of have this flushing of the island. When you have large amounts of wastewater being distributed into the groundwater and this groundwater seeping out into the ocean, most of that discharge happens like right at the beach face, and especially at low tide. And so when you have even a small amount of nutrients out on the reef from wastewater or fertilizer, it can really make a large difference on the reef. It can change the entire reef from a very diverse ecosystem with many different types of plants and animals to a monocrop, or what's in this case a sugarcane field of seaweed that dominates the bottom environment and outcompetes everything else. And in extreme cases, like out in front of Kahului on Maui, you can see organisms that may be native being very opportunistic and just dominating the seafloor. In one case, I saw what we call zoanthids, and they're this crazy, fleshy, coral-like organism without the coral skeleton, dominating like a 4-inch thick, fleshy carpet full of photosynthesizing, particle-eating little things. And it's a really wild what can happen to a reef if you just over-fertilize it. The one thing to remember, though, is that this doesn't have to be a permanent degradation. We have shown some research that the reefs are quite resilient. If you cut off that fertilizer source, the reef will recover close to what it was like before, and fairly quickly. We can fix this, and the reefs can be resilient. We just have to act soon to ensure that we can get them back to a place that is conducive for a high diversity of native species.
We are looking for a few heroes, mentors, trailblazers, innovators, a passion to change lives, spark curiosity, open hearts, and awaken minds, help students answer the question, who am I? This could be your calling, but this is no job. It's the journey of a lifetime. Be a hero. Be a teacher.
We're talking with Dr. Henrietta Dulai about her work tracing pharmaceuticals and the path they take to contaminate the environment through cesspool connections to groundwater.
For my part of the research, I use chemicals that are unique to human consumption. Specifically, I look at pharmaceuticals. So those are medications that everyone takes, most households take. And so once our human body metabolizes it and eliminates it, we flush it down the toilet. And here we go, we have a tracer, and we can play detective and go and look in the environment where we see those medications pop up and appear in streams, groundwater, or the coastal ocean getting out to the reefs.
Can you tell me what types of pharmaceuticals or medications specifically you are tracing?
An example I would say is caffeine. Caffeine belongs to stimulants, so it's counted as a pharmaceutical. And most households either drink coffee or energy drinks. Therefore, caffeine is a very good tracer for urban wastewater. Caffeine is natural though, so it degrades relatively easy. So if we find it, we know we are relatively close to the source. Another medication that we look at, and it's also relatively biodegradable, is ibuprofen. Many people pop a pill for a headache. Well, eventually it comes out in a stream. Again, if you find it, we know we are relatively close to the source. Others, such as some antibiotics, are very resistant. We can follow them for many days away from their source. And so those are good to kind of map out regions where we have cesspool inputs, but you can't really tell how close to the source you are.
Are the chemicals something that we should be concerned about being in our water bodies, or are they more just indicators of cesspool leakage?
And unfortunately, there are not many studies here in Hawaii, but I can cite a few examples from other places. For example, there has been a study looking at corals that if they are exposed to caffeine, then they become less resistant to coral bleaching and are not able to fight the high temperatures. Other studies looked at the effects on ethinyl estradiol, that synthetic estrogen found in birth control pills, and they found that fish populations can collapse from the exposure to this chemical. Antibiotics promote antibiotic resistance in the environment. This is all documented now. Many of our cesspools in the state are right near the shore, near the coastline, where groundwater level is very close to the ground surface. And so these cesspools are from the bottom up inundated by groundwater. And as the tide moves, it moves that groundwater level higher up, the cesspool floods, it gets flushed out, all the chemicals get out into the groundwater. And as the tide recedes, we see that groundwater loaded with chemicals flowing out, and we have documented this process in multiple places around the island. And I must disclose that we really focus on areas where we have high density of cesspools. So that's why we have such high levels of detection. Our frequency of detection is that we find pharmaceuticals in roughly 8 out of 10 samples. That's high in environmental studies. We really focus on finding the locations that are most notoriously leaking into the environment. Perhaps that can then inform the state which areas are in the highest need of being replaced and upgraded. Our island geology is very porous because it's made up of basalt that has many conduits in it that allow water to flow freely. And so the water can travel from point A to B relatively fast. Also, because of the relative young age of the islands, we don't have thick soil layers with lots of organic matter. Pretty much what's discharged into the rock is very little remediation happens to it, is discharged out into the coastal ocean via submarine springs or to streams with groundwater discharge.
Where does your research go next?
We will try to see the effects of these compounds on the ecosystem, and that will be a collaboration with other scientists who study ecosystem health. And also, we want to understand more about the hydrology. Our status quo right now is that we already have spring tides and king tides that flood cesspools, but with sea level rise, we expect this problem to actually be worse because more cesspools are expected to be flooded. We have evidence that for sure, without a doubt, shows that there is this hydrological connection and chemical connection between cesspools and the environment. But it's not the problem only in Hawaii, but elsewhere. Converting to wastewater treatment plants could be one way, but perhaps how we dispose of our wastewater, treated wastewater, is also something the state should invest in.
Hawaii's cesspool maps, coupled with researcher findings of high nutrients, pharmaceuticals, and fecal contamination, are helping to make vital determinations about the most critical areas for upgrading our cesspools. As we work toward better wastewater management, continuing to monitor water quality is also vital to informing ocean users and ensuring public health. Learn more at voiceofthesea.org. Follow us on social media at Voice of the Sea TV. Mahalo for watching Voice of the Sea.
Exploring Our Fluid Earth is the dynamic curriculum developed by the University of Hawaii's Curriculum Research and Development Group. The award-winning Fluid Earth and Living Ocean textbooks are now interactive and online. New activities, updated content, and a teacher community. Exploring Our Fluid Earth is now freely available. Find out more at exploringourfluidearth.org.